I ain't drunk. I'm just drinking.
But you're so high.
Oh man, you know I ain't high.
But you're so high.
Yeah, well I just take a little sip every now and then.
But you're so high.
You ought to be ashamed of
Stay
yourself.
drunk all
Oh,
the
come on now,
time.
you all don't feel like that.
Hey kids, bam, we are back. And for those of you that have been following the TrollHunter series, this is obviously the setup for Inav, which a lot of people have been waiting for. Sorry for the delay. But anyway, one of the things we're going to do, I'm going to walk through this and try to do it fast because this stuff's kind of boring. So I'm just going to run through. I'm going to assume that you have flashed your board already with Inav. Inav is a Google Chrome app, just like Betaflight. So go into your Google Chrome, go into the App Store, type in Inav, bam, there you go, and that's it. But it works very, very similar to Betaflight. And people make the mistake thinking that Inav, if you can do Betaflight, you can do Inav, and it's very, very different. So that's why we're going through this. Choose your board, Omnibus. Let's do that. I'm doing an Omnibus F3. I'm just going to do 1.73. You can do the newest one if you want, but I haven't tested this one, so I don't want to mislead anybody on 1.8. 1.73 full chip erase for an Omnibus. And we're going to do this, load online. This part's just like Betaflight, no big deal. And it didn't work. So, hang on 2 seconds. I don't think I rebooted it right. It wasn't plugged in. Haha, dumbass. There we go. Now let's try it. Jeez. There we go. Went into DFU. It's doing the board erase. See, this is why you shouldn't do instructional videos in the morning when you sleep. You know, no drinking. So, getting this, and it's going to erase the board. And I already have TrollHunter set up. And I just made a backup of him, and I'll dump it back in after this is over. But I want to show you guys what this is from the ground up. So, we're almost there. It flashes just like Betaflight. There's a couple little nuances, though, that we do need to go through. Calibration is nothing like anything else. And a lot of features in here. So I'm just going to show you how I do it. And we will do it. Now, the boards that I recommend for Inav, if you guys want to build a drone, there's our beep. There's our bird. So, I recommend you use an Omnibus F3 or an F4 or an F7. The reason I say that is because they already have built-in barometers, which is what controls your altitude. So that's just what I recommend. I'll show you how to do Bluetooth connection too. But we're going to hit connect. Takes a second. It's not as fast as Betaflight because there's a lot of information going back and forth. Okay? So what you're going to see here, maybe, I wonder if I should reboot the computer, is the bird. No big deal. And if I move the TrollHunter, you'll see that move. Now, my orientation is not right or anything like that. Now, to calibrate, let's assume my orientation is right. Like if I tilt him forward, he's actually going to go to the side. So let's just fix that real quick. Configuration. This part's kind of like Betaflight. And we go down to here. Board configuration. Where are we at? There. Woo, been a long day. And we're going to go -90 on him, if I remember right. Save and reboot. Okay. That's going to reboot. Okay. Reconnect. No big deal. All right, so now what we want to do is you have to do a calibration of the compass and the flight controller. All right. You do not just hit calibrate accelerometer and go away. That is not what you do. What you do is in Inav, if you go to Inav webpage, and I'll put a link to it in the description, and you'll have this, or you guys can do a screenshot of my screen here. Do a screenshot of that. Bam. Okay. That is the calibration process. It's very, very simple to do. So what you're going to do is you're going to end up hitting this button, the calibrate accelerometer, 6 times. So we're going to lay the bird totally level and hit calibrate. And you should hear it beep. I don't have a beeper in this. No big deal. Then you're going to flip it upside down and you're going to hit calibrate again. You'll hear a beep. Then you're going to point it, set it on its side so it's pointing to the right. This is the front of the bird. Hit calibrate again. Then pointing straight up, calibrate again. Straight to the left, calibrate again. And straight down, calibrate again. And you are done. Does that make sense? Okay, now make sure that your board alignment is done first. Okay, trust me on that. So you want, when you tilt your bird forward, you want that thing to go forward like that and make sure everything's copacetic, and then just follow this. You're just going to click this button 6 times to go to that. Easy, easy, easy. Now what you want to do. After that is done, it should say compass is calibrating. Mine does not, but that's okay. Now we're going to hit calibrate magnetometer. Now the thing that you want to do is you want to have a reasonably long USB cord plugged into your bird, because what you're going to do is you've got about 60 seconds, I think, or 30 seconds to rotate this bird on all 3 axes 360 degrees. Okay, so you're going to hit calibrate magnetometer, and then it's going to go into basically a time, and then you're going to roll the bird all the way around the X, then all the way around the Y, then all the way around the Z, full 360. So I'm going to go ahead and do that real quick, and you'll see what I mean. So I hit calibrate, it goes into a time. I'm going to rotate it around and then rotate it back. I'm going to rotate it all the way around this way. I'm not doing it all the way because this is a huge drone. And then we're going to rotate it all the way back around again, and then we're going to spin it on Z, and we're going to do that as well. Bam, bam, bam. And then if you still have time, just keep rotating it, moving it, moving it, moving it, moving it until that calibration button that you see in the middle there goes back to normal. Bam, there it goes. All right, easy enough. Put this down. So there you go. Now it says accelerometer is not calibrated because I didn't finish that. Compass is calibrated. So I'm going to do this. Calibrate. I'm just walking through this to get it done. I'm not actually calibrating it properly. It might not let me do it this way because I'm cheating. That's all right. I'll load my backup later. We'll get it that way. All right, good enough. Now, there it is. Okay. The CPU load, everybody's copacetic. So now what we're going to do, everything, let's assume that I did this properly. I did not. I'll load the backup before this video is over just so everything works. Presets. I really don't recommend you use these. You can see 5-inch racer, 5-inch GPS. These are supposedly, maybe they fixed this on the new. Like for TrollHunter, I would hit, that's tricopter. I would hit 12-inch general purpose probably. I know on every version of iNav I've used, the PIDs are absolutely horrible. So if you guys are building a 5-inch drone, like an EWAD or what I built for Warlock Hunter, his is a 250 size. I've got PIDs that work really well for those. It's a good starting point anyway. And I also have PIDs that work for a large one, like a 600 millimeter, which is Warlock Hunter. So just let me know if you guys need those, but I don't even bother with presets. I really don't. Ports. Now, for this one, USB virtual COM port, always leave that there. That is what you're plugging into your computer with. Never turn that off. UART1 I have set up on MSP as well. That is for my Bluetooth connection, and that is the only thing you need to do for the Bluetooth. All right, no big deal. So if you don't have Bluetooth, you don't have to use this. My GPS, I wired into UART2, and I'm going to go over to here, and I'm going to hit, where'd it go? Sensors. My bad. GPS. Leave that default. That's fine. So UART2 is our GPS. And then UART3, this is an omnibus, F3. UART3 is where I have my serial or my receiver plugged into, okay? You do not have to set anything up for the compass. The compass is built into the GPS and has its own designated ports on the board. So this is, you don't even need this right here. This is for Bluetooth. I can have that off. You don't need it. Or you could use it for something else. Like say you guys are putting sonar on it, which I think is kind of a waste of time, but you could wire those into UART1 and do it that way. But I'm going to leave mine enabled because that's where my Bluetooth is at. So let's double check. UART3 is our radio receiver. UART2 is our GPS. Leave the baud rate alone. And then peripherals over here, black box, run cam device. You can actually set up a run cam, like a run cam split or something like that, which is a cool idea. But that's where I want it. So we're going to do save and reboot. Okay. Reboot this guy. Have a drink of coffee. Like I said, it takes a bit for it to boot up. All right. Now, something that is important that I have not told you guys yet. When you are setting up your bird, your drone, I want you to have the props off and the battery plugged in. And I would also advise that you unplug your FPV transmitter or your VTX because you're going to be sitting there for a while and it's going to get really hot. Just unplug that or turn it off if it has an off function. Because depending on how you're wired your drone, you might not have your GPS on if you're only plugged into the USB port of the computer. So trust me when I say, whenever you're going into Inav, plug in your battery and then plug in your USB port. Your life will go much smoother, okay? So we have presets we ignored, ports we're done. Let's go to configuration. All right, quad X is what we're setting up. If you're doing a Y4, you can go all the way down to the bottom. Well, there it is, Y4, I'm sorry, I'm thinking of Betaflight. Like I have a Y4 drone, flying wing, which I will be building very soon here. My wing drone, I'm going to be using this template, and you can see it changes aileron, motor. So we're going to stick with quad X. And the rotation and motor order is the same as Betaflight. So if you're used to that, that's good. Enable motor and servo output. Notice up here it says it's disabled. I don't know why they do that. It's just a safety, I guess. ESC protocol. This thing's kind of weird with Inav. Inav will not run D-Shot. I don't know why. So I run everything on multi-shot. Even if you have a really good ESC that's fancy and does BLHELIS and whatever else, nope. It only goes to multi-shot, which is fine for a drone, because drones, you're not flying like a real quad usually. ESC refresh rate, I usually leave at 2 kilohertz, no big deal. And leave servo refresh rate at the lowest usually. I do enable don't spin motors, because I enable air mode. And then disarm regardless of throttle value, leave that there. Minimum throttle, this is one of those things that if you put the stop on and then you enable air mode down here and you guys arm your bird and the motors don't spin or they just spit a little bit, you don't want that, because if you're up flying really high with the drone and you kill the throttle, you want that thing to come down, but you don't want to come down like tumbling, right? So bring this up to a whatever, something like that. That's usually where I pop it. That way they spin nice and tight. I like my drones to spin, when you arm them, almost enough to lift it. Not quite. You don't want to see it move off the ground. But I want all 4 of those blades spinning proud, okay? All right, enough of that. And this stuff is kind of self-explanatory. And if you guys have any, I'm going through this fast. If you have any questions, please just ask me. Accelerometer, it's automatically going to detect. Your compass, it's automatically going to detect, which is right here. Barometer, which is built into the board in our case, is going to be right here at the top. Okay. And rangefinder we don't use, and a pitot tube. Pitot tubes for airplanes. Rangefinders for drones, I don't use them. My drones go too fast for rangefinders. It doesn't work. Doesn't work the way you'd think. This is your board orientation. Okay, this is what I changed, because I put in TrollHunter, I put my board sideways, so I had to rotate it, and actually it needs to be this, but that's okay. Your mag alignment, this is, don't mess with this, don't mess with that, because you're not using separates. This right here is very important. If you're using a radio link GPS like I'm using, or if you use the U-Block specific, usually, and I know for a fact, with the 2 different models of GPS I use, you have to put it in a CY270 flip because it's actually upside down and spun around, okay? This is important, and I'll show you how to set this later. Let me go back up to this top to explain what these do. Gyro is just like in Betaflight on a quadcopter, it's your gyrometer. Accelerometer, same principle. Your compass is needed because that tells you if you guys are flying programmed waypoints, you have to have it pointing north, south, east, or west so that it knows where it's at. It will not fly without a compass. It'll fly, but it'll probably fly to my house or to the North Pole and you'll never see it again. So that's important to have. And the barometer is also detecting the air pressure. And that's why I put a little piece of foam over it on the board when we do the final install. So wind doesn't get in there and disturb the pressure or else you get false reading. This is what holds your altitude. And then GPS is obviously GPS. This gives you your actual coordinates in space. That is needed. I don't have it turned on yet. You'll see in a minute. If you're running a board, let's see, you can run just this way. I usually do this. That's your low pass frequency cutoff filters, asynchronous mode, synchronized loop time, blah, blah, blah. It's all kind of confusing. I usually do all, and I set these relatively low. But you have to remember, I am running an F3 processor in mine. You want to make sure, I'm trying to remember where I set this, that you don't overload your CPU. Right now I'm at 1%. Okay, this is how I set mine up. You don't have to do it this way. Not a big deal. Receiver mode, this is exactly like Betaflight. We're going to go serial bus in my case, because I'm running on FR Sky, and we're going to go S-Bus. Just like Betaflight, no big deal. If you're using you do have voltage on the omnibuses, so I do use this. This is just like Betaflight 2, minimum cell voltage, maximum cell voltage, warning voltage. So when my battery gets down to 3.5 per cell, it starts beeping if I have a beeper, or on your OSD, it starts flashing. No big deal. And your voltage scale, and there's plenty of videos out there on how to calibrate your voltage scale. Usually it's pretty close. Omnibuses usually run 1 or 2 points behind, so we're going to do it this way. And then current sensor. If you're running a current sensor, you want this on. I don't. I run it off. Now, down here, GPS for navigation. Yeah, kind of need that. And when we reboot, you'll see this light come back up. Ground assistance, just leave it disabled. I mean, you could do it that way, I suppose. I don't use ground assistance, but whatever. Magnetometer declination. Wherever you live in the world, you live on a different magnetic field relative to the north. And some countries you have to, there's some areas of countries you have to change that declination. It's automatic. Just leave this at 0, no big deal. 3D, we're not flying 3D, so I will never fly 3D. I can't even fly in regular. Servo gimbal. If you want to put on a servo gimbal output, you can do that right here. I am putting on a gimbal. I don't think I'm going to hook it up to my transmitter though, because my gimbal has the board in it and it will automatically tilt and I can set it. I'm not a photographer. I'm not going to get up there and like dial my dials to make shit work. No big deal. Leave this off. Telemetry output. I'm running OSD. I really don't care about this. I don't think telemetry is that important if you have an OSD. 3D mode, which we're not going to use. Analog RSSI input, I'm not going to use. Multicolor red, green, blue LEDs. If you guys want to put some cool colors, like the drones that I've built for friends, I usually put LEDs on there with it scrolling back and forth and tells you when it's got GPS and all that stuff, like I did for my brother Lincoln and my brother Warlock. OLED, I do use. That's the organic light emitting diode. You don't have to. That's strictly for fun. Black box, if you want to use it, I'm not going to. Just sucks up CPU. Forward auxiliary channels to servo outputs, I am going to use because I'm using a camera switcher. That's basically so I can use motor outputs 5 and 6 for controlling external devices. CPU-based SPI interface, we don't need that. External PWM servo driver, I do not have any external servos on this machine, I do not need it. We do want on-screen display, and we do want air mode on. Save and reboot. Now, when I hit save and reboot, this should go away, and GPS should come up. Let's see what happens. Okay. Now, if you get this, you need to upgrade your firmware before you can use the config tab. Just hit connect again. What that usually means is you've tried to reconnect before it totally rebooted. I do it all the time because I'm impatient. All right, there we go. Bam. Where'd my GPS go? Let's see what we got. Why is that not working? I probably put it on the wrong port. That's okay. Yeah, it didn't save it. That's interesting. So we're going to put in peripherals, sensor, sorry, GPS. There we go. Now let's do it. I shouldn't have enabled this. That was an accident. Too early. All right. So we're going to reboot. All right. And as soon as I find my plug, sorry guys. This is boring as shit. All right. We're going to connect back up. And I'm actually going to dump the backup back in because it's easier to reference in this video of what I'm doing. So let's go into desktop. And I do have a backup. TrollHunter. There we go. And I'm going to copy all this. And I'm going to dump it back into CLI. Hit enter. And the Inav has a lot more information in it than Betaflight. So you can see this is taking a lot longer than if you guys have ever done a diff dump in Betaflight. This is a lot more extravagant, obviously. So hang on just a second. All right, type save, just like Betaflight. Betaflight CLI and Inav CLI are extremely similar in how they work. My motor's got a lot of calibration. It's okay. I'm actually going to disable that. So now we've got our GPS back up. Let's see where I went wrong with that. Serial GPS. Nope, that's right. Just like that. 57,600 is where I put that at. So if you have GPS issues, I think I said leave this at 38.4. Put it at 57.6 in case you don't see it pop up here. I am going to disable motor outputs because, believe it or not, I have my props on. But this is a folding quad, so I've got everything, a folding drone, so I've got everything set up. Let's go back. Reconnect. And we're going to go through and just double check that I wasn't misleading you on a couple things, because it does get pretty involved. Everything is calibrated, everything's copacetic. Let's see, presets we don't need to worry about. Let's go back through ports. Yep, like I said, 57.6. UART3 is still our radio, and this is my Bluetooth configuration. Quad X, multi-shot. 1075, see, that's where I have my minimum throttle on this guy. And then I've got all of these set here at 1 kilohertz, and my CPU load is 1820, which is fine. We're good with that. All this is working. I did this on purpose. For some reason, this is still here. That needs to be on serial. S-Bus, we'll leave that alone. That's all good. North America. Servo gimbal, we have that set up. Yep. Okay, that's good enough. I'm not, yeah, we'll just save that. So we're not too off track. All right. Let's reboot. I never use auto connect, by the way. Not on Betaflight, not on Inav, nothing. Okay, there we go. Everybody's copacetic. This is turned off on purpose. Let's go down to Failsafe now. Now with Failsafe, here's how I do it. Always return to home. Right here, you've got land or drop. Drop is just like Betaflight. You turn off your radio or you lose signal, it's going to drop to the ground. I don't recommend that. We've got return to launch. Used it, okay? And land. Land is good too. Other than that, you usually don't have to test any of this stuff or do nothing, which is terrible. It'll fly away. Return to home. So if you run out of range, basically how home works with INAV is when you guys put your drone on the ground and you arm it, wherever you armed the drone, that's what it remembers as home. So if you arm it your driveway and you fly a block away and then you hit return to launch, that's what I call it, or return to home, it will stop, turn around, fly back to your driveway, and land on the driveway. If, here's another example, you arm in your driveway, you fly a block away, then you land in a football field, you disarm, then you rearm, and then you fly another block away and you hit return to home, it will now go back to the football field and land. Does that make sense? Okay, so return to home is what you want. I leave this stuff alone. I've never even had to play with it. PID tunings. This gets a little bit more involved in Betaflight. These are the PIDs that I'm using for TrollHunter. Yeah, I open up my degrees per second. This is your speed of flight, okay? I'm going to explain flight modes in a minute, but basically your roll, pitch, and yaw rate. And it's kind of like rates in Betaflight. These come default, I want to say it's 600 or 800, which makes for a very slow DJI Phantom type of flying. It keeps your angle limited, okay, if you guys are going to be flying in angle mode. And even if you're in acro mode, like EWAD and things like that, you know, it doesn't flip as fast. I pump it to 1200, 1090. And that's just how I fly it, and it seems to be pretty nice. So, barometer, sonar, altitudes, and altitude. These are your PIDs for those. PIDs for your mag. PIDs for your GPS. I usually leave all of this at default and test everything first. Usually I don't have to play around with this too much. I do change these. This is TrollHunter, the big drone. This is what I set up for those PIDs to start with. Then I'll dial it in from there. These preset PIDs suck. At least they do on this version. So I use these for big birds. And actually my little birds aren't much different. Little meaning 250 millimeter. And then you've got your strength, LP cutoff, and transition, just like Betaflight. We don't have to worry about those. But I do open these up because it's very lethargic. Okay, if you're flying a drone in angle mode and you have these set at the default, so it banks really slow, and you have this set at default, which I think is 45. Don't quote me on that. And you get a really strong wind, it might be hard to get at home because you're not going to be able to have that aggressive pitch that you need. That's why I open these up. Yaw jump prevention, I usually don't have to mess with this. If you have stuff that's doing strange things, you might have to. But yeah, I don't think I change anything on here. I keep everything pretty much stock if I can. The more filters that you add, guys, the more issues you end up having. And it's the more shit you have to tune. So you want to focus on changing this, and double check me on down here. Okay? Advanced tuning. Now, this is pretty important. I put my vertical position borrow rate at 50. It just tends to hold my altitude hold better. No big deal. Attitude. User control mode. This is another thing that when you're flying in GPS hold or altitude hold, or you're repositioning in return to launch mode, this is what affects that. And this also affects your speed of waypoint flying. If you're flying waypoints, meaning you have uploaded GPS coordinates into your system and you are looking to, fly over to your buddy's house, crap on his head, drop off a beer, and come back. Okay, that's what this is. So if I put this down to 500, that's a navigation speed, centimeters a second. That's as fast as it will go on a program point. So if you program that point to go to Blackhawk's house at 2,000, but this is set at 500, it's only going to go 500, okay? I usually open these up to 1500. But that's for program speed and when you're flying in a controlled mode, which I'll explain those in a minute. So I open my stuff up to this. I do not use mid throttle for altitude hold, but you can. Basically, whenever you go into mid throttle, it'll kind of sit there and use the barometer. I don't usually use that. Hover mode, hover throttle. If it hovers at 1,000, you want to change this to 1,000 if you're using this. It's kind of like beta flight, not a big deal. This I leave pretty much alone. I don't really change much of this because I use the Radio Link GPS, which is an extremely nice GPS unit. If you use that cheap shit, like 12 bucks off Amazon, you might have to play with these. If you have a problem with your GPS, call me. Return to home, return to launch, and landing settings. Here's what I do. I can't remember what the default is on this, but I put current, extra, fixed, max, and I put at least, always. Now, I'm not going to explain what all these mean, because this is just getting too long. Return to home altitude mode. Basically, I tell my birds, default on this, I want to say is 1,000 centimeters, which is not enough. What this basically means is when I hit return to launch, if I'm at 100, let's say 100 centimeters off the ground, which is pretty low. Now, let's say it's at 2,000 centimeters off the ground, which is what, 60 feet, something like that. My birds, I put at 3,000, which is give or take 100 feet, and I hit return to launch, it will stop right where it's at. It will go up 3,000 centimeters, which is, let's call it 100 feet, at least. Okay, now, what at least means is if you guys are flying at 200 feet and you hit return to home, it will stay at 200 feet or 6,000 centimeters a minute and fly home and land. But basically what I'm saying here is anything below 100 feet, I want you to go up 100 feet vertically and then fly home. The reason I do this is if you guys are flying between telephone poles or trees or whatever the case may be, most trees are not 100 feet high. They're usually 60 or 70 feet on a big scale. I make mine so it clears any shit, unless it's a cell phone tower, it's going to clear it at 100 feet. So if I'm at 5,000 centimeters, it'll fly home at 5,000 centimeters. But if it's below this number, it will stop and go straight up vertical to at least 100 feet and then come home. Bam. Climb regardless of position. I don't usually do that. Do you want to come home tail first? No, I have mine rotate and they face me. Because a lot of times I put big high-powered LEDs on the front of my drones and I want to be able to see them coming if I take off my goggles. It's just something I do. You don't have to. But if you enable tail first, it'll literally come home and backwards, which I don't really know why you would. Do you want it to land after it returns to home? Yes, I do. I like them to come home and land. Usually, if I hit return to home, it's because I'm lost or I'm bored or whatever. Usually I don't let them land. Usually once I get it close to me from return to launch, I flip it back into acro or angle mode and I just fly it home. But you can let it land and it will come all the way down, land, and disarm. It's pretty cool. But I usually do have this set because if you're using return to home as a failsafe, you want this thing to come home and land. Trust me on that. Let's see, landing vertical speed. This is common sense. How fast do you want to come down? I have it 300 centimeters a minute for my default. Minimum vertical landing speed at altitude. If you guys set your stuff up just like this, you'll be fine. You can figure all this out. This is not rocket science. Now, minimum return to home distance. This is basically if I am within 1,000 centimeters from where I took off, it's just going to land. Does that make sense? So if I start, I fly and I go, say, 10 feet away from me, and I hit return to launch, it's just going to land right there. It's not going to literally go up 3,000 centimeters, come over and come back down. It's just going to land right there. If I'm greater than this, then it will do the real return to launch. So if you guys always want to return home, set this at a stupid amount, like 10 centimeters a minute, or 10 centimeters, I'm sorry. And if you fly more than 10 centimeters away from yourself, she'll go into return to home. Not a big deal. Okay? Return to home abort threshold. This is basically saying if it seems to get far more than 50,000 centimeters the opposite direction of going home, it aborts. It's kind of, they call it a moron failsafe or something like that. Leave it alone. Don't even play with it. Emergency landing speed, 500 centimeters a minute. Leave that at 500 centimeters a minute. If you guys set your stuff up like mine, it's going to scream ass home, and it's going to look like it's dropping out of the sky very fast. But once it gets about 50 feet off the ground, all of a sudden it goes slower and comes down to a nice soft landing. If you're using a really heavy bird, like I might have to tweak this on TrollHunter because he's a little bit heavier. You don't want him smack into the ground with inertia. Fixed wing settings, these are all for fixed wings. Like my flying wing I'm going to do, we'll play with that later. So that's it for this configuration. Receiver, just like Betaflight, guys, exactly the same. Make sure when you hit your throttle forward, throttle back, yaw right, yaw left, make sure when you hit it on your radio, it's doing what it's supposed to be doing in here. And then set up your channel map. I'm not going to go through all this. There's billions of videos on Betaflight out there. This is the same damn thing. This is the same damn thing. No big deal. And you can watch your scaling here. Okay? I'm not going to go over that. This is probably the most important right here. Now, let me give you a very good word of caution on this. Do not go into this screen and hit save without your battery plugged in, because if GPS is not lit up, you will not get position hold, return to home, waypoint, home reset. You'll not get this. You'll just have a few options. You have to have the GPS enabled when you get to this screen, or it will not think it has GPS, and you will fuck everything up. So don't do that. So arm, set it up just like Betaflight, guys. Set it up the way you want to arm. Okay? Slide your slider over. This is how I do mine. Angle mode on a big bird. I have angle shot across the board. I just do. I don't fly big birds in acro mode because you just don't have the reactionary power to come out of a dead speed fall like I do with EWAT or my Y4. So like TrollHunter will never see the light of day when it comes to acro flying. He's always going to be in some form of self-leveling. It's just too big of a bird, and I've got a servo gimbal on the, or a brushless gimbal on the front, and that'll screw up the gimbal if you're flipping upside down and all that crap. So you don't want to do that. Horizon mode, I never ever use with a drone. Turn assist. Turn assist, you can read all this in the Inav information. Turn assist, basically, if you're flying forward and you hit yaw, it'll basically fly it kind of like an airplane. It automatically flies for you. So you can just hit your throttle and I don't know. I never use it. You can read about it. Heading hold, that's kind of like headless mode, head adjustment. You don't use these guys. With a drone, that's toys. You don't use that. Camera stabilizer. If you guys are using a dual or 3-axis or single-axis servo gimbal, you can actually enable this, wire the servo gimbal into the flight controller, and then assign this to a channel, and you can well, actually, no, you don't. I'm sorry. You wire this into motor outputs that you have assigned to your servos. If you're using a gimbal without an accelerometer in it or a gyro in it, this will basically forward your flight controller gyro to your dumb, if you will, gimbal, and it uses your flight controller power to auto stabilize your gimbal. My gimbal has all that stuff in it, so I'm not using it. Navigation altitude hold. Now watch how this is working. I'm using channel 5 for my modes. Okay, channel 5, if I am switched all the way down, here's my switch, and my switch is all the way down, actually up in my case, I am angle mode only. Okay, so if you look down here, the next mode I have that's channel 5 is navigation altitude hold, and there's nothing here because when my switch is all the way up, I'm going to be over here, and it's only angle mode. If I put my 3-position switch to the middle, notice here's the middle, now it kicks in altitude hold and angle mode. Does that make sense? So basically it's going to self-level if my switch is in the middle, and it's going to maintain altitude. This is not position hold. Position hold uses GPS to hold it into space, okay? So basically, let's assume you have a 5-mile-an-hour wind, and you put your switch in the middle, so now you've got angle mode and nav altitude hold. There's nothing under here. It's basically going to hold that 10 feet above the ground, but since you have a 5-mile-an-hour wind, the drone is going to float away at that level. Does that make sense? I don't use altitude hold a lot by itself, but I put it in there just for fun. If you guys are doing video, photography stuff, altitude hold can come in kind of handy. The third position on channel 5, my three-way switch, notice this is lit up, which is position hold. Position hold is only GPS, okay? But since it will light up on angle, it will light up on altitude hold, which is barometer, and it will also light up here. That's going to enable our barometer, enable self-leveling, and enable the GPS. So now what it's going to do is it's going to sit still in space and sit there. End of story. That's all it's going to do. Now, you can fly in this mode. You can fly in altitude hold mode, and you can fly in GPS hold mode. But remember those numbers we changed in advanced tuning? It's going to be slower. So let's say we put our position or switch into third position. So we're running GPS hold. You take your hands off the sticks. The thing just sits there in space if life is good, okay? You can move your pitch and roll stick and it will fly forward or to the right. And then when you let go of your stick, it will just stop wherever it'll have a little bit of, inertia, but it will stop eventually and hold that position in space. Also, in contrast, if you hit your throttle up, throttle down while you're in any of these two modes, it will slowly raise or slowly descend, okay? So if you're flying in, let's say, altitude hold only, and you basically have your stick centered, your throttle centered, and you are just moving forward on your pitch, it's going to maintain that, let's say, 50 feet up in the air as far as you want. If you raise your throttle up a little bit, it'll slowly raise the bird, and if you bring it down, it'll slowly drop the bird. Now, if you flip your switch back up to angle only, your throttle will react fast, just like it normally does in any other bird, okay? So, you can fly in all these modes. I use return to home on a separate switch. You do not have to. You can actually put that on channel 5 as well if you want to have switch combinations, or like with my buddy Lincoln's, he had a 6-channel radio. I made him an angle mode, a GPS hold, and a return to home all in the same switch, and I left out altitude hold because I don't need it. It's just, you don't really need it. So yeah, that's that. And let's see, return to home, back to this, sorry. I put this on its own switch. Return to home switch will override any other mode. So if I'm flying over here and I flip this on, I put it over here, I flip my 2-position switch, anything other than down is going to be off, and if it comes on, it will override any of this stuff, and that thing will stop, return to home. You can lay your transmitter down and go have a sandwich, and your bird will come home to you. We call this the oh shit switch. If you guys are running out of battery or you're lost, I get lost all the time. If I'm flying somewhere where I'm not used to and I'm 300 feet, 200 feet up in the air and I'm half a mile away from home, chances are really good, kids. I have no fucking clue where I'm at. So I hit return to home, bam. And once it starts looking familiar, I might take it back out and fly myself, or I'll just go eat a sandwich and let it land. No big deal. That's what return to home does. To be safe, what I usually do is I will set up the failsafe in my transmitter that if something happens and I lose communication in the transmitter, it automatically throws this channel high and kills every other channel. All right, does that make sense? You don't need to do that, but it's a double failsafe for me, okay? The other thing about return to launch is your throttle will not work, okay? You will not be able to raise or lower the bird, but you can reposition the bird while it's landing. So if this thing's not going to land exactly where you took off from. I've taken off from my driveway and landed with return to home 2 feet away from where it took off. That's good enough for me. I don't care. You can dial that in. I don't care. I just want the bitch back into view. That's all I care about. Or at least landing within 10, 20 feet of where I'm at. But my radio link GPS is good enough to land almost within feet or a foot of where it took off. But you can reposition when you're landing, or let's say it's returning to home and you want to just play around. You can spin the yaw, you can spin the pitch, you can spin the roll. Or you can reposition it while it's landing and it's nice and slow. It's kind of cool to do. Navigation waypoint. This is also on a separate switch for me. And I almost never use this, but if you guys want to take a Bluetooth from your phone or USB from your phone and download the app, you can upload a map of, let's say, from my house to one of my buddy's houses to drop him off a beer. I can upload those GPS coordinates and up into the flight controller, and when I'm flying in any mode except return to launch, so let's say I'm in position hold, or I'm in altitude hold, or angle mode, and I flip this switch, it will literally take those points that we programmed into the controller and take over and fly to Blackhawk's house, or fly to my neighbor's house, or whatever, and do whatever I've told it to do. The only thing that I know of that overrides it is return to home, or if you just turn it off, then it reverts back to whatever you had it set here. I don't use waypoint programming very much. Back in the APM days, I used to, just for fun. I'm going to use it on my drone wing, but I don't really use it on a drone. It's fun to play with. If you've never done it before, it's a hoot to do. But if you guys are into photography and you want to program your bird to go fly around a water tower and take photography of a tree or whatever you're doing, then it's kind of handy. But it's fun to play with, just so you can say you've done it. I don't use it. Actually, I've never used it on iNav. I've used it on Mission Planner, and it works really well. And I'm sure on iNav it works great too. Home reset. You remember what I told you guys earlier, when you're flying, you land in a football field, you disarm, you rearm, now that's home. You can actually set this up on a switch, and you can be wherever you want. And when you flip that switch, usually a momentary switch, it will literally reset the home position, and that is the new home. But this is dangerous, because if you're 500 feet in the air and you accidentally hit that switch and you hit return to home, it's going to fly back to that 500 foot high point in the air and sit there forever. That's it. Yeah, so yeah, you might want to use that. Ground control station navigation. You're not going to use that unless you're using what is that? Robotics telemetry and stuff like that. You're not going to use it. Beeper, I usually do have this set up on, for my stuff, it's like channel, what do I use that on? Channel 8 or some crap, and I put it over here. With drones, a beeper's almost a waste of time, because you usually don't crash drones. You usually land drones unless something really bad happens. And if you do crash a heavy drone, you probably don't want to find it anyway. But if you guys want to put on a beeper, that's just like Betaflight. You can turn on and off LEDs, no big deal. You can turn on and off your OSD, your kill switch. Some people like to have this. I've done it before, and it's exactly what it says. Absolutely no matter what, whatever mode you're in, wherever you're at, you flip this switch, bam, that bitch drops from the sky. Now, to me, it's pretty much the same thing as disarming. If you guys get into a situation where you need to just kill this bitch no matter where it's at, you are going to want to just disarm it. Works the same way. No big deal. Failsafe. My failsafe is return to home, but that's exactly what that is. It is a return to home failsafe. I don't know why it's in there twice. Camera control 1 and 2. This is basically servo forwarding. This is what I'm going to eventually use for using my camera switcher. So when I rotate my knob, I will basically wire this into channel whatever, remap channel whatever to motor output number 5, and then I'm going to say, okay, my transmitter channel 12 is my pot. I rotate my pot and it changes my cameras. I can do a separate video on that if you guys want to see it. I'm not going to go through it now, it's too much. Save this. Done. Adjustments, just like Betaflight, you can make all sorts of PID, in the air PID changes, things like that. I'm not going over that. Lots of people like Bardwell and people have done that. I'm not doing it. It's just redundant. Servo is the same thing. If you guys are getting into external servo control, where you put your camera on a little servo and you want to pivot back and forth, you might want to use this. I'm not doing that in this one, so there you go. GPS. This is really nice to make sure your GPS is working. Look, that's where I'm at. Bam. No big deal. I don't use it for anything but that. Motors, you're going to have to calibrate your motors with iNav because it does not run D-Shot. So it calibrates the exact same way that your Betaflight old school motors did. So what you do is you leave your battery unplugged, you enable this, turn your master all the way up with your props off, then you plug in your battery and you'll hear it beep and do that funky calibration tone, and you slowly drag down your slider. You have to do that with everything in iNav because D-Shot is the only protocol you don't have to do that with. And since iNav does not run D-Shot, make damn sure you've calibrated your motors or it will fly like a weeble wobble, and that would be bad, okay? But again, You can look up on YouTube 1,000 different ways, 1,000 different people that can show you how to do this. It's stupid easy. Or just shoot me a text on YouTube and I'll tell you in 3 sentences how to do it. It's not hard. Now, I'm not going to go over LED strip. I'm not going to go over sensors. I'm not going to go over tethered logging. And I'm not going to go over black box because all of that stuff is covered in multiple videos out there. And this is getting long and boring. So I am going to go into OSD. Okay, and I'm going to explain what these do. I'm going to put it in PAL just so I have a bigger screen. It should get bigger. There it is. RSSI signal strength. This is all, I'm going to turn all this stuff off. This is all pretty much the same with a couple little differences as Betaflight. I'm going to turn all this stuff off. But I'm going to show you the ones that you probably want to have that I use, okay? RSSI, if you're using RSSI, which is how much power you have between transmitter and receiver on your radio, you're going to want to use this. Battery voltage, always. We're always going to use battery voltage. My computer's lagging really bad. I don't know. Video might be getting too long. Let me reboot this and I'll be right back. All right, sorry about that. Let's see if this is a little bit better for us now. So we're going to go back into PAL. And the only reason I'm doing it in PAL is just so it's a bigger screen so I can put the stuff up here. RSSI, like I said, if we put that on, that is going to tell you your signal strength. We all know what that does. And you can position it just like Betaflight. Your battery voltage, I definitely recommend you do. That's so you can see your battery voltage. And remember when we were up at power, under configuration, you get down to a certain warning, it will start flashing, just like Betaflight. Throttle position, I don't usually use this, to be honest. You can, though, if you like all that crap. Fly mode. I think fly mode's pretty useful with iNav. I don't use it with Betaflight, because I fly in acro all the time anyway, but this will tell you if you're in return to home. It will tell you if you're in altitude hold. It will tell you if you're in GPS hold, and stabilizes angle, as we all know. And this is nice because if you get a failsafe, like you lose transmission and you see this automatically turn to RTL, you know what happened. So I do use that. Your heading puts up a little arrow up here, if I remember right. Oh, it's your actual degrees. Your heading is, 0 is north and then 180 is south, and you get the idea. You should use it. It comes in handy if you know where you're at, but I rarely do because I'm an airhead. I don't pay attention to shit like that. I do put on my altitude because it's fun knowing where the hell you're at and how high you're up. That's your altitude. Variometer I do not use, or numeric variometer I do not use. I do use fly time. I do not use on time. Some people that are anal like to know how long it's been powered on, but I usually don't power on my bird unless I'm flying it, so I don't really care. And your bird just sitting there idle doesn't suck up a ton of juice, so I don't care about on time. Crosshairs, artificial horizon. You guys all know what this is. That's Betaflight crap. If you want to make it, pretend you're in a warplane or something like that, useful, but I don't. I'm sorry, it's just too much shit in the way. GPS speed, I've played with this. It does work. It tells you how fast you're going, but I don't know how accurate it is. You really want to know how fast you're going, you have to use a PID-02. And with an airspeed, you can use this if you want. It's kind of fun to play with. GPS satellites I always use. I like to know what my satellite lock is. And there you go. In this case, it's showing there's 14 locked. Now, one thing I always do, and you see this on my EWAD stuff or my other, any of my drones. Any drone I run, I have this on here. Longitude and latitude. Now, the reason I do this, when you're flying, you really don't give a shit because you guys, nobody's that smart unless you're Rain Man, figuring out where you are in space relative to these numbers. But here's the beauty. If you go down, let's say you're flying over the woods and you go down in the trees, okay, your OSD is probably still being recorded in your goggles, or at least to the point where it hit a tree. Go back into your recording and you look at the longitude and latitude and you type in these first three numbers here, first three numbers there into Google Maps, and it will literally walk you right to where the last known position of your drone was. That's why I use this. Money in the bank, kids. I've actually used it and it has saved my ass. make sure, if your goggles have DVR, guys, make sure you use it. I don't use it for recording YouTube crap. I use it for saving my ass when I crash somewhere. And I'm telling you right now, best insurance you can have, and especially having your longitude and latitude recorded, you can literally plug that into Google Maps and it'll walk you right to where your drone was last location was. And chances are good it's within 3 feet of there. Direction to home, you can use this. Shoots up a little arrow up here that rotates as you're flying. Oh, it's right here. This will rotate as you're flying and point to the direction of home. I don't use it, but you can. Distance to home, I do use. I use that with my altitude, and I usually put it right under my altitude. This is how far you are away laterally. This is vertical, this is your altitude, this is your lateral. So if I fly 1,000 feet straight above my head, this will say 1,000, this will say 1 foot. Make sense? If I fly 1,000 feet up and 1,000 feet away, these are both going to say 1,000. That gives you a relative geometry of where you're at. Make sense? Cool. So I do use that because I like to know how far away I am. Think of kayaking, guys. If you're flying a fixed wing airplane GPS, it's a little bit different because you've got a lot longer flight time. My wing is going to get like half an hour, 40 minutes of flight time with battery I'm using. My drones don't do that, my quads. So think about it. It's like kayaking up a river, down a river. Yeah, it's easy kayaking down, but you still have to paddle your ass back. So if you're out half a mile, if you're out 2,500 feet and up 1,000 feet, you best be turning your ass around and getting home because you still have to come home, okay? So I do use how far away I am. And it also helps you if you crash too. If you have a VTX, it's OSD enabled. You can use it here. Meaning you can turn it on and off through Betaflight. I do not use those, so I do not care. And here's your PIDs. You can do this for whatever reason. I don't know why you would. I don't use it. I suppose if you're dialing it in, you can do it. And that's it. Font manager, you can change them. I usually run my own font, which is Mugsels. The reason I use Mugsels is it's very accurate on the battery. Okay, if you use the stock Inav or Betaflight battery symbol on you see these right here? They're not accurate. It's like your battery goes down a third, it shows it being dead. This Mugsels one, it's got more DPI in the font and it's better. I just use it. If any of you want it, yeah, I use it in Betaflight actually. I can send you this file. It's no big deal. All right, I think that's really about it. Black box, LED strip, and all this crap. You guys can look that up. I'm not going over that. A couple of things just to be noted with Inav. I think I've covered most of the basics. First thing is your GPS has to get 3D lock or it's never going to be armed. You will not be able to fly. So what you're going to do is if you plug in your battery, set your bird on the ground, and you try to arm it, chances are good it's not going to arm. It has to find at least, I can't remember. I think you can change it, 6 satellites, and it has to have an IDOP of a certain value before it'll let you arm. I use the radio link GPSs, and dudes, they find that fucking GPS shit like in 20 seconds. Cheaper ones can take up to 5 minutes. And the GPS I use is $22. Don't buy a cheap one. Buy the radio link. I'm telling you right now, it works the best. I've tried a lot of them, and I'll never go back. I put radio link GPSs on all of my birds. If you have a beeper on your bird, when you get GPS lock, it'll make this dee-dee-dee-dee-dee sound, and that means it has got GPS lock. If you use LEDs, it will actually, LEDs, and you assign them to GPS, they will flash blue when they start, they will flash red when there's nothing found, blue when they find satellites, and green when it gets 3D lock. Plus it'll do the beep. Or you can watch it in your goggles on the OSD. You'll see it has how many GPS satellites it has. So that is a very quick rundown. I might do another video later of more of the high-tech stuff and high-tech tuning that you can do in Inav, but this video has really been long enough and I'm bored with it. So this should help you guys get started. Please shout me out if you have any questions and I'll be glad to help. So until then, kids, keep shiny side up. Take care. Bye-bye.
Bam, JJ! Bam, JJ. Hope you like fishing.